Hey everybody, today I want to go through a solution on how to solve a system using elimination. And if you take a look at the system I've given you, you'll notice none of the coefficients are the same. So I want to tackle a solution where you have to manipulate your equations. Okay, here we go. So there's your system. You see it up there. We know, of course, that we have to number those equations so we can talk about them properly. Now, you have a choice when you take a look at those two equations. Neither the x variable or the y variable have the same coefficients in front of them, nor do they have one equation where you could manipulate it easily to get the other. What I mean by that, really quick, let's just say that equation 2 had a 6 in front of the y. Well, then pretty quickly we could see that if we doubled the first equation, you would now put a 6 out in front of that y. Now that they had the same coefficient, you could eliminate them. So without both of those equations, having the other variable's coefficient with a common factor, man, I know that that's a lot of terminology, then what it's going to mean is we're probably going to manipulate both equations. So here we go. There's nothing in particular that says I have to eliminate my x nor my y. So you have an option. Are you going to multiply your equations to get the x's be the same or multiply them to get the y's? I'm just going to go ahead and multiply them to deal with the x's just because the x's come first. There is nothing more important than that. So what that means then is I'm going to multiply the first equation by 5 and the second equation by 2. Okay, what does that do? Well, if I take equation 1 and I multiply everything by 5, then that's going to give me this new equation. And since that equation's been unsimplified, I'm going to label it with a different equation number. That's now equation 3. I'm going to do the same thing with equation 2. You can see in green, I'm going to double it. That means that equation 2 is going to change to this. Same thing, I unsimplified it. There's my new equation number. So now what I'm going to do is I'm going to focus on equation 3 and 4 to solve that system. Since my x's have the same coefficient, I know that if they have the same coefficient, then I'm going to subtract. I'm going to subtract in the order that gives me a positive coefficient. So you'll notice that if I take 3 and then subtract 4, that's going to give me a positive 7y, right? My x's are going to cancel out. So I get a positive 7. Had I gone through and subtracted in the opposite order, I'd have a negative 7y out in front. I don't want to deal with negatives if I can avoid it. Okay, take a look on the right side. I'm now going to take 3 and subtract 4, so 25 subtract 32, and there is a negative 7. Okay, that gives me a nice easy equation to solve for y. Now that I know my y, I can replace or sub in that y value of negative 1 back into, and I want to use one of my original equations. One of the equations that was given to me because I know that that's the most correct. You know, like I didn't maybe make a mistake in it. So I'm going to sub back into equation 1. Equation 1 just because my numbers are smaller. So what does that mean then? That means I have a 2x. I'm going to replace my y with negative 1. So 3 times negative 1 is negative 3. And there is that equation of which I can solve very quickly. And now that I know both my x and my y, write my solution as a point of intersection, making sure I'm in alphabetical order, and I am good. So I would expect to see all of that gold communication, and then obviously your green algebra solution. Okay, I am hoping that that helps you to be able to go through and solve a system using elimination. I hope that that really helps you with your practice. Okay, best of luck.